Hello again, guys, and yeah, I'm back with another video. Still continuing work on the first law of exponents, which is law 1. And today I'm coming back with a twist, and what we'll be doing is simplifying. We're going to be simplifying using the laws of exponents, but this time we are going to be working backwards. Okay, we are going to be working backwards. Let's see how is it that we are actually supposed to work backwards. Now, if you recall, I'm gonna write this here. If you recall, I said that if I have a to the power of m times a to the power of n, then the answer should be a to the power of m plus n. Why? Because when I have two similar bases multiplying one another, then the exponents of those bases will add under just one base, right? So we will have a to the power of m plus n. Now, the application that is going to be needed here in terms of solving this particular problem or simplifying it is us going from here to here. All right, when we move from here, we end up here. When we move from here, we should end up here. So if I reverse this, right, if I take this to this side and this to this side, it means that if I have a to the power of m plus n, when I reverse this, I should have a to the power of m times a to the power of n. What does this mean? It means that a to the power of m plus n tells me that m and n were under the base of a. So I'm going to write them separately now by saying a is actually m has the base of a separately, and n has the base of a separately. So what I have when I separate this from this, I will have a to the power of m times a to the power of n. This gets me here and this gets me here. We know that for us to end up at a to the power of m plus n, we started at a to the power of m times a to the power of n. All right, so for us to simplify this, we have to work backwards. All right, we have to move from here to here. All right, in all of these particular parts of the problem. Now let's get into the work and see how what I'm explaining is supposed to work. So when you simplify this further, the first thing we do is to reverse this from here to here. So our base is 5. So we have to separately write our exponents under the base of 5. My exponent is x and 2. So I have to separately write these two exponents under the same base. So what I will have is 5 to the power of x multiplied by 5 to the power of 2. All right, minus what I did here, I should also do here. I'm going to write these two exponents under the same base separately. So I will have 5 to the power of x times 5. I can write 1 here, but I think you should know that we never write 1. 1 is always invisible, okay? But we do know that there's 1 here, right? Divided by, when I go at the bottom, I will have the same thing that I did here and here. I will also do here, meaning that I will write the exponent of x and 1 under the same base of 5. So I will have 5 to the power of x times 5. I almost wrote x. I will write times 5 to the power of 1. We know again here that this is supposed to be 5 to the power of 1, but we never write 1. When there's no number here, we know that it's actually 1. Right? Now, when you simplify this further, we have to take out a common factor at the top, meaning that we now have to factorize. I've not done factorization at the moment. If you don't understand it, you'll have to bear with me, as I will only do problems on factorization later. But the factorization that we have to apply here is that of taking out a common factor. A common factor is what we find to be similar on the parts that we are supposed to factorize. So when I look at this part, this first part of the problem, I see that I have 5 to the power of x. I see that I also have 5 to the power of x on this side, meaning that 5 to the power of x is my common factor. So I'm going to take it out, okay? So I'm going to take out my 5 to the power of x, 5 to the power of x. I'm taking it outside. I'm taking it away from here and here, all right? So when I remove it from here, I've taken it out. I remain with what? 5 to the power of 2. And 5 to the power of 2, by the way, guys, is 25, right? So I'm going to write this now as a number. When you punch 5 to the power of 2 on a calculator, it should give you 25. So that's what I'm going to write. I'm going to write 25, right? Minus, when I take 5 to the power of x away from here, I remain with 5. Do you see that? I remain with 5. So I've taken out my 5 to the power of x. And when I take it out here, I remain with 25. When I take it out here, I remain with 5. Divided by 5 to the power of x times 5. Now, this 5 to the power of x is going to cancel with this one. Okay? And when they cancel, or rather after they cancel, I will remain with 25 minus 5. 25 minus 5 obviously leaves me to remain with 20 divided by 5. Now, when I say 20 divided by 5, what am I supposed to get? I'm supposed to get 4, right? Let me just be sure. 20 divided by 5 is 4. Yes. When I divide 20 by 5, I get 4. So this becomes my final answer. All right. That's how you basically simplify this particular problem. I'm going to do another one just here. So that was our first problem, right? That was problem number 1. Let's check out problem number 2. So problem number 2 is 3 to the power of x minus 3 to the power of x minus 2 divided by 8 multiplied by 3 to the power of x. Okay. Now, when I look at this problem, I realize that, okay, this 3 to the power of x minus 2, I have to reverse, right? I have to reverse it from here to here. Or rather, I have to reverse it from here to here. Okay? Meaning that when I reverse it, I'm going to write these exponents under their separate base of 3. All right? So when I proceed, this one is already separated. So I write it as 3 to the power of x minus, I separate this exponent with its base of 3. So it's going to be 3 to the power of x multiplied by this base, which is 3 to the power of negative 2 along with the exponent of negative 2, right? I've reversed it now from here to here. Okay? Now, when you proceed, I'm going to go at the bottom. Write everything as it is. 8 times 3 to the power of x. Now, at the top, I have a common factor. I don't know if you can see the common factor. Can you see it? Can you guess it? Please guess it for me. The common factor is 3 to the power of x. So I'm going to take out 3 to the power of x. When I take out 3 to the power of x, what do I remain with inside the bracket? I remain with 1. When I take it out here, I remain with 1. Minus, when I take it out here, I remain with 3 to the power of negative 2. 3 to the power of negative 2, guys, when you punch on a calculator, should give you a value of 1 over 9. Okay? 3 to the power of negative 2 should give you a value of 1 over 9. Let me just be sure. Sometimes you can think you are sure about these things. I want to find out that you are incorrect. Yes. So 3 to the power of negative 2 should give us 1 over 9 divided by, at the bottom I write everything as it were, 8 times 3 to the power of x. And then this 3 to the power of x will cancel with this 3 to the power of x. At the bottom, when I say 1 minus 1 over 9, I get 8 divided by 9, right? Or rather 8 over 9 divided by this 8. All right. Now, when I proceed, you can get the answer of this thing by just going to the calculator. But when I proceed, I will have the reciprocal of this 8, which is, let me write it like this for you guys to make you understand the part of a reciprocal. A reciprocal is the inverse of what you have. So if I have 8, the reciprocal of 8 is 1 over 8. Okay, so I will have 8 over 9 divided by this line I'm writing now as a division sign. This division line I'm writing as a division sign. So I will have 8 over 9 divided by 8. But I know that this 8 is over 1. So the reciprocal of 8 over 1 is 1 over 8. Now when I write the reciprocal of 8 over 1, I should have this sign changed to a multiplication. So if I have 8 over 9, I will have 8 over 9 times 1 over 8. Then this 8 will cancel with this 8. So my final answer will be 1 over 9. Okay. But you can get the answer using your calculator. You can get the answer using your calculator. Let's see when we use the calculator. What I have was 8 over 9, right? 8 over 9 divided by 8. I get 1 over 9. So you can get the answer by using your calculator. But this is how you basically simplify this particular problem. Okay, that's it for today. I'm going to come back with another video, continue with solving such problems, and in the next video will be also solving for x. So be ready for that. For now, just keep on practicing, and yeah, enjoy your maths basically, and kindly likewise subscribe to my channel, like the video, and of course tell your friends that you found a better person to make maths easy for you. For now, it's a goodbye, guys.